Welcome everybody, my name's Sam and I'm the CEO and co-founder of SkyCiv Engineering. Today I'm going to take you through a full demonstration of how to use a structural 3D program. I'm going to take you through it in two parts, the first part being modelling and the second part being the analysis or post-processing. Here you can see our interface. You can see all our buttons on the left to build and load our structure, as well as buttons at the top as a taskbar to view the other options such as save and loading, editing, tools that we have, some output features, settings, and our solve button. We've also got some great support and documentation that can help you along your way. Documentation is actually embedded within the window itself, so you can view what you need to look for, what you're looking for, and check the different aspects of the software to learn about the part that you're trying to build, while then continuing into back into the user face without any disruptions to your workflow. Finally, we have our view buttons here on the right. These will enable you to make changes to our visibility settings at any point across the analysis. Okay, so let's get started with a very simple frame, and that's what we're going to try and build today. So I'm going to start just by adding nodes. So nodes are basically the beginning and the end of every member. And you can see here that my units are in imperial. I can go through in settings and actually change this through my settings. So if I want to go to metric, I can select metric from that button there. But today, I'm going to build our structure in imperial, and I'm going to save that. So as I was mentioning, we start and end all of our node positions from the start and end of each member. So I'm going to go through and just tab and entering. I can enter my structure, some of my structure properties or coordinates, just by tab and entering really quickly. You can see I'm going to make quite a slender frame. So something like that. And now a great tool that we have is actually being able to open up a data sheet and view our coordinates through an Excel-like spreadsheet. And I can actually copy these numbers, paste them down, and then build out a Z component to that. So maybe a 20-foot length there. And apply that. And you can see that's copied and pasted all my nodes across there. And you can sort of see some of the structure starting to take place. Everything from the graph is actually selectable, so I can select here and make changes to my nodes there. And I can also hover over and see what the XY coordinates of those nodes are. So that helps when you're building out your model. Okay, so I'm going to go back and I'm going to start connecting some of my members. And I'm also going to show you a few shortcuts of how we can do this. So this first method is just clicking and dragging between nodes. And that enables me to build my model much quicker than I would having to enter it through the side menu. Alternatively, I can go under members and add my node A to node B, so for instance 5 to 6, and enter. And you can actually see as I'm entering them in, they will highlight what node I'm referring to, so it just enables me to visualize where that member is going to exist. Another way we can do is actually clicking and dragging through another node. So you can see here that this is not joined to node 10. I've connected node 9 to node 11 via this member 7, but I haven't actually connected node 10. Now, obviously within analysis, that is an incorrect way to do it because this member is not connected to member 8. But what we can do is I've joined two members there. I can actually go under advanced and then repair model. And it's going to tell me there that the node is not connected. The node 4 is not connected to node 8 to member 8. And I can see now, once I submit that change, that those changes have been made. So now I can see that my nodes are separating those members correctly. I'll just finish up connecting my members. And I also want to show you that the nodes are actually still always connected to these members. So if I end up dropping this node here, say by 5 foot, it'll actually stay connected to those members. So that makes making changes very easy because you don't have to change anything else, you just have to change the locations of those nodes themselves. Okay, so now that I have some of my members assigned, I might want to have a look at some of the detailed attributes of these members. So for instance, member 11, 12 and 13 might all be of a different section. section. Right now there's section ID 1, which I can see is denoted by the black sections. Again, if I open up my data sheet and looking at sections 11, 12 and 13, I might want to change these to section 2 and apply that. And I can see now that they've turned blue. And I've also seen that there's a section that's been added to my legend here. Some other features that you can change with your members are the node fixities. So I can actually make these joints, for instance, I can make them pin joints, but right now I can see that they're fixed. If I want to make these changes, I just hit custom, and I might want to make this a hinge joint. So I'm looking at node B, which is 3, and I'm just going to put a roller support there. A hinge connection there, and hit apply. And I also see that that's denoted there by a dot, so I can actually see that this joint is no longer fixed. I've also got some great advanced options, and what we like to do here at SkyCiv is actually we really like to make our interface very simple and very clean to use. So we hide a lot of these settings, knowing that maybe not the majority of members will need to use them, but if I want to use these, I can just simply toggle the advanced option open and see I have more options available to my to use. So I can change the type. For instance, if I'm going to add a cable, I'll change this drop down to cable. And I can also angle rotate my member, and I can also offset my member. Now I'm going to come back to these settings in just a minute. First, I want to assign some sections to these properties, and then I'm going to show you the effect that angle rotation and node offsets has on these members here. So I'll just close that advanced option, and I'll go back to building my model. So here we can see that we have two sections. We've got the black sections and the blue sections. Now, they haven't been defined. One is just a default section, but I actually want to attach some attributes or some dimensions to these linear elements. So I'll click here, and I'll go into my builder. Within the section builder, I have a whole range of tools that I can use, and this is implemented within all our software, including SkyCiv Beam and SkyCiv Section Builder, which is a standalone program. Here I can choose from some preset options that I have. For instance, hollow rectangular, circular, I-beams, box girders, and I can actually change the dimensions here just through the diagram itself, or by changing under the dimensions tab. I can also choose my materials here. So if I want to make this an aluminium section, I can select aluminium here. And I can also run some other operations such as rotate and translate. I can also mirror my structure as well. So if I have, for instance, a channel section mirroring about the y-axis, will allow me to flip that section and continue to build my model. I can also add second sections by unticking this clear others and just adding another section here, and now translating that in the Z at 2 inches. You can see how you can build multiple shape sections. And I even have the option to choose different materials if this is a composite section. Okay. Next, I can even load sections from my database. So we do have American, Australian, British, Canadian, and European sections that are pre-built into the software itself. So I'll go into AISC and maybe load a W shape. I've also got some great custom options that I can run. I can add a point shape, which will allow me to define the Z or the XY components of the shape, as well as a line shape, which will allow me to run a section through a series of points, and finally import a DXF file. For now, I'm just going to choose to delete these sections and stick with my original W shape from my AISC library. Another thing I can do is actually save and load custom shapes. So if I create a custom shape that might be built up of multiple materials with cutouts, and it's taken me a while to build, I want to save that and use that on future projects. This area allows me to do that and also share with the rest of my team under the enterprise account. Finally, when I'm happy with my section, I can hit calculate to review the results that's run through a full FEA analysis on this section itself. So the results are extremely accurate because a full FEA has been run on these cross sections, and it now enables you to have accurate results for your custom shapes, no matter how custom these shapes are and how difficult they are to build. So now I'm happy with that result. I'm going to hit submit. I can see now that my legend has updated itself to show the I-beam and the section W831 that I've used for the black sections. And again, I'm going to do the same for blue, and this time I'm just going to load another shape from my AISC table. Maybe I'll go a rectangular section there, hollow section, and I'll run through and submit that. Again, it's updated itself in the legend. So you can see my structure is really starting to take shape here. And the next thing I want to do is go back to the area under members that I was discussing earlier. And I want to review this member 11. And I want to make some changes under the angle of rotation and some node offsets. Now, a great feature here to use would be the 3D renderer. This will allow me to bring my structure to life and review what it looks like in real-life 3D space. So you can see that the I-beams that I've added along with the hollow rectangular sections, and I might want to make these changes such as rotation and offsets that I was mentioning through the 3D renderer because it enables me to look at things more clearly and what they're doing in 3D space. And you can actually see that I've got my wireframe mode on, so that just enables me to review the different elements, and especially when it comes to joints and getting those members correct, it helps just reviewing what the sections are. But I can turn that off, and I can also turn on color sections to look at the different types of sections we have there. And I can even add nodes if I want to make changes to my structure through the 3D renderer by making changes to the nodes there. But for now, I'm just going to focus on these members. So I'll go back to wireframe so I can see what I'm working with. And I'm going to rotate this member by 90 degrees. Now you can see that it's rotated, but I want to lift it up as well. So that's another change I want to make. And maybe I want to do something similar to these two members as well. So again, the 3D renderer just enables you to make these changes a lot easier. And I can see that I'm going to make an offset by 8 inches. And the reason I'm making it in the Z is because it's on the local axis of this member. So the Z, since I've rotated it, the Z is now down. So I hit apply, and I can see that that's now been lifted on top of these I-beams. And I might want to do something similar for this member. And for this one, I'm going to rotate by 105 degrees, and again make the same offset by 8 inches on either side. And again for this one. So just the 3D renderer just enables you to view it what it's actually going to look like and make sure that you have your dimensions correct with the sections, as well as some of the offsets and rotation functions that you might need to apply to these members. So I'm happy with that. I'm going to go back to the wireframe mode, and I can actually see that my members are lifted up within the wireframe mode as well. At this point, I might want to add supports to my sections. And to do that, I can make, I'll just open up supports tab here. And I can actually make a fast way to do this. I'm going to make a fixed supports at the base of all these points. I can actually do comma separate, so 1, 2. And then I can even comma separate and do 6 to 8 to actually collect the 6, 7, 8 nodes. So if you're working on a really big structure, this enables you allows you to add the supports much easier just by doing it all in one step. And then I can choose whether I want all these supports to be pinned, roller, spring, but for now I'm just going to have them as fixed supports. And you can see in one step I've managed to add all my supports. We've also got settlements here, so if you do want to apply some settlements at the supports, you're able to do that within that settlement button. Again, you can see the structure starting to take shape. The final thing I might want to add are some plates. So plates are really easy to add. We've tried to build them connected to nodes, so you can connect them just by clicking and dragging with the plates tab open. And double clicking on that last one will allow the plate to be created. So you can see I have a plate with 4 nodes here, and by clicking that plate I have a few more options here available. I can choose a material ID, the plate thickness, I can rotate it as well if I need to rotate the axis of it, or I can offset the same way I offset the members. I can also choose what state I want to run, whether it's plate stress or plate strain. Now obviously with this member we might want to apply some meshes to it. So I can do that, that's important to get accurate plate results. So I can do that through our meshing tool here, and just by clicking mesh, or under advanced and plate mesher. Now the great thing with the plate selection is you can do multiple plates at a time, so I could do the same way I did the supports. If I had multiple plates, I could add them all through there, or I could just hit all, and it'll collect all the plates that I want to mesh at that time. I've also got some great options here, so I can do triangles, quadrilaterals, or structural quadrilaterals as my choice of mesh type. Under structured quadrilaterals, I can choose how many times I want to divide the plate up into, and I can mesh that now. Now it's really easy to go back and unmesh. It's a feature that we've really worked hard to build onto to ensure that users can make changes to their meshes really quickly. So I'm able to, again, unmesh or just remesh through the plate mesher. And maybe I want to go back to my structured quadrilateral at 5x5. And it's going to just say that it's going to override this existing mesh. I'm happy with that. And I can see now it's back to the mesh that I wanted. So I'm happy with the mesh and the frame, and it's really my structure is really starting to take shape. And now next thing I want to do is add some loads to the structure. So I'm going to start with some point loads, and I'm just going to apply them at nodes 9 and 3. Again, I can do these by comma separation, so 9, 3. And it's going to highlight the nodes at which these point loads are going to be applied to. Now I can control my X, Y, Z magnitude in terms of kip. And maybe I want to do a -2 kip force at either end of this member. I can hit apply there, and that'll make apply those loads there. I can also apply point loads just by at the midspan of a member, just by going under point load and changing this to member. And now I can do 7, 25% along the span of that member. And let's go for a slightly larger force at -4 kip. And what you can see is the actual forces are all in proportion to each other. So I can see 2 is half the size of 4. And by using this scale here, I can actually scale up or scale down to review what those loads are. So similarly, I can hold S and scroll, and that will have the same effect. At this point, I'm happy with my loads. I want to continue and add some distributed loads. So I can add a distributed load, say on member 8 there. So I'm going to enter 8. You'll see that it highlights to show me which member I'm working on. And I want to add a -1 kip foot to a -2 kip foot. And I want to offset them by 25% at each end. And on this side as well, I'm also going to add a different load group. I'm going to maybe add this as a live load group. So L. And I'll apply that there. Oh, sorry, I had to offset at 75% to finish. So starting at 25%, finishing at 75% along the span of the member. And I can see that. So, I mean, that shows that the errors that you will receive, they're all denoted down here in the status bar. And they allow you to review the error that was registered as to why that load wasn't being built. Again, I can go back and make changes to this just by hitting this toggle button here under 1, or by clicking and selecting any of these loads. And I can hit delete. So everything is encompassing with the software as well is all very dynamic and allows you to make changes using keyboards, and even click and highlight to add and delete multiple members. And I can even Control Z to undo those changes that I've made and re-add those forces back in that I've originally deleted there. So it's quite powerful in terms of interaction that I can do with clicking, as well as using the side menu to add and edit the various elements of my structure. I can also, quite like point loads, I can add a moment. So I can add moments at nodes or members. So exact same as a point load. And for this case, maybe I'll just do point load at node 10 or something like that at 20 kip foot or 5 kip foot. Finally, I might want to add some pressure. So I can add pressure to this plate of this member. And so I just select the plate number. Again, it's going to highlight. And I can choose local or global. So for instance, in this case, maybe the force is acting locally to the plate. So it's acting perpendicular to the plate. And my local axis, I can also review what my local axis is here under local axes. And I can see this plate, the Z is going into the face of the plate. So if I want to add a pressure load that's in the face, that's in the direction of the face of the plate, I can add that here under Z, and I can actually review where that the axis of that plate is. So again, and maybe I want to make this a wind load, so I'll denote a W for there and hit apply. And I can see now that that pressure is exactly how I want it. It's up going into down, and if I needed to scale that up again, I can see where that pressure is being applied. Now I no longer need the local axes, so I'm just going to go ahead and turn those off. But I can review my loads independently as well. So if I want to change off some of these load groups, I can. So maybe I don't want to look at the wind load for now, or if I want to remove all loads and just review the structure on itself, I can do that as well. And I've also got some other options such as remove plates, remove nodes. So you can really change the way that you're viewing the structure and work in a way that's convenient for you. So finally, I've added all my loads, I've built my structure, and now I might want to make use of the load combinations and self-weight features that we have with the software. So I might apply, self-weight's really easy to apply. I can just go into self-weight and just toggle that on, and I can choose what direction that's occurring. Now I've built my structure with Y being up, and I'm happy with that, so I'm just going to go ahead and hit apply because I've got the gravity in the Y direction. Going back now, I want to maybe apply some load combinations to these different types of loads that we have. So we did have some dead loads, a live load, and a wind load here. Well, now we want to apply some load combinations to that. So I hit load combinations, and I have this in a format that I can control, add multiple combinations here. So I can call this load combination 1 and apply a factor here of maybe 1.5 to the self-weight, 1.2 to the dead loads, 1.5, etc., and apply those. And I can see now that that's saved in my options. Or I can actually import from a number of different design codes that we have pre-built within our software. So for instance, you might want to load one from the United States, Europe, Canada, Australia. For now I'm just going to load a simple one from the United States under the ASD ASCE design code. So I can hit display just to review what those are, and I can see my different load combinations, and I can also assign the loads that I've built, so the names that I've given my load groups, to the ones that are required for these design codes. So for instance, self-weight I'm going to apply as a dead load, LG as a dead load, my L I'm going to apply as a live load, and my wind load I'm going to apply again as a wind load. So it makes it really easy to assign the load combinations that I've built, so the load groups that I've built, to what is defined within these design codes. So I go ahead and hit import, and now I can actually go back into and review all those different types, or even go in my data sheet if I want to make some changes, mass changes. It allows me to do that with speed and ease using the data sheet. But I'm happy with those preset load combinations, and I'm ready to save or solve my structure. Now I'm going to go ahead and just save this job. And this will save to my my cloud. So it's already registered. It will actually register if you have a structure built with that name. So it is very convenient, so you won't override some of your files. And so I'm just going to do demo 11 for now and hit save. And that's going to save within my cloud storage. So obviously I can jump from another computer and access this file, or I can send this across to someone else, or under the enterprise account, I can have someone else review what I've built within my own team, because they have a shared folder. And it makes it really easy to collaborate and to come up with a model that is going to work for everyone in the team. Some other options that I have under file is I can actually input some job details. So again, if I'm working in a team and this is a very important structure and I want someone to review it, at least we know who the original designer of the structure was, and I can put notes here for the next person to review. So you know, it might be that please review rear member 11 for analysis. You know, you can put any notes there, but it just makes some extra job information and makes your collaboration a lot easier within your team. So I can go ahead and submit that. and that's going to register and save with my file. And I've actually got autosave on. So in your settings, which is just under account settings, you can change this to manually control when this job is saved. But for me, I'm happy to have autosave automatically resave the structure every minute or so. Some other great features is you can import and export files. So I can import a DXF file if maybe I get drawings from an architect, or import from a CSV file. Maybe I've built my model using some of the functions that Excel have to offer. I can also export in the same way, so CSV, DXF, but I can also export in STL, which obviously is good for reviewing in 3D space. Some other options I might want to make the most of is I can go back and edit some of the load groups if I want to change the name. So live, wind, maybe I want to change this to dead. It just allows me to do that without having to rebuild all my load combinations. I can also take some great screenshots. So this might be a good opportunity to take a screenshot of what the structure version 1 might be. So I'll put version 1 build. And that'll actually save locally to my hard drive and also save within my camera roll. So I can actually review that screenshot that I've taken. And this is an automatic generated thumbnail that will be used on your project reporting and also within your file management storage. And you can also take more screenshots from here. I can download them or I can delete them. So I can review these images at any time I want. I can also review CSV results or also the CSV structure and export my nodes or export my members through the output just there. Some options within settings that are relevant for modeling might be perspective. You might prefer just to build your model in perspective mode and give it that sort of 3D look that might help for you to visualize how the structure is being built. But for now, I'm happy with everything. I've built my structure. I'm ready to solve, and that completes part 1 of the demo that I'm going to be running through, and that is how to build your structure. Thank you. So welcome everybody to part 2 of the SkyCiv demo of SkyCiv Structural 3D. So I'm going to just pick up where we left off. So I'm going to reopen the file that we built in the previous video. So there we have our frame with the plate. And I'm going to go ahead and, in the last video, we built the members, the loads, the supports, the plate, we meshed the plate, we applied loads, and we also applied some load combinations to the structure as well. So for this part, I'm going to solve, and when I go to solve, I've actually got 3 options that I can run: a linear static, a buckling analysis, or a p-delta analysis, which is a non-linear analysis. Today, I'm just going to run through a linear static and buckling, and I'm just going to go ahead and click that second option. And it's actually going to run the repair model function. And what that does is just picks up all the areas of the model that haven't been built correctly. So as I mentioned previously, when we were building the model, I had a member that ran through all these nodes without picking up his individual nodes. So what this is actually telling me is that node 13, for instance, it wasn't connected to member 9 that ran through there. Now this is because I meshed my plate after I built the members. So what this is doing is saying, do you want to connect the plate to this member at each point along the way? That's essentially what it's asking me. Now I want to do that because my plate will actually run on top of the section that is the I-beam section that runs along there. So I'm going to go ahead and hit accept there. So what that's done is it's solved the structure and it's also made those changes that it was asking me previously. So I can see it's solved successfully. My interface has changed now to red, so I've got all my result option buttons here that I can choose from. And I can also select from my load combinations. So these are the load combinations that we built in the previous video, just to, and you can select which one is important to you or kind of go through them to define which is the kind of critical load combination for this particular structure. So I'm going to go ahead with just load combination 1, which is the one I actually pre-built myself. And I'm going to go ahead and turn the reactions on. And you can see now that all my reactions it supports have an X, Y, Z component to it, as well as a moment reaction as well. And I can actually toggle these on and off. So maybe I want to really just focus on the force and the Y. And I can click and drag all these labels as well. So if I need to turn on certain results, I can do that just by, if I need to review certain results, I can actually click and drag so I can see what that moment force is there. I got a shear force diagrams as well. So we can see there are, it's quite, again, a cluster of information. So there's a few ways that we can look at this clearly. One is just to click individual members and isolate those members. So maybe we really want to focus on this front column here. And I can, again, click and drag. So if I want to move these labels to make them easier to view. Another thing I can do is also scale. So if I've got this whole structure and I can't quite see what that result is there, scaling it might make it a little easier. Again, otherwise we just select that member and see exactly what's happening within that particular member. So maybe this is a critical member. I know we put some loads on this member 7, and this might be a good opportunity for me to take a screenshot that I'm going to use in my final analysis report. So throughout the report, let's focus on this member 7 as a critical part of our design. So I'm going to save that screenshot. I don't need to open my camera roll just yet. And I can continue through my results that I can toggle through. Again, you can change this at any time. So if I want to look at a different result now, maybe I'll go to ULS4 and I'll look at the moment forces again. Got some large moment forces here. And you can also change the direction of which moment force you're looking at. So I can look at the Y direction as well. So for instance, this one has some Y because we applied a moment around that area. Next is axial forces. So obviously you want to look at the internal axial forces of the members, and we've got two options here. So one is a simple version where it just allows you to look at the kind of cleaner version, a cleaner way to represent these results. You've got red in compression, green in tension, and you can see the arrows are showing that as well. And you've got a little C here as well. And anywhere where you see an asterisk, it just means that the force isn't uniform throughout the member. So for instance, this member back here, it's in tension, and it is 0.012 kip in tension the whole way along. Whereas this member right here, it's roughly 12 kip in axial force, in compression. It's got an asterisk, which means it's variable. It changes from one point to the other. So I'm going to go ahead and hit normal and review that variation. And it's quite a minimal one. It's 11.2 to 11.8, but it still is a change. You might get some drastic changes in axial force, which is why you might want to, for instance, I don't know if it's happening anywhere in the structure, not quite, but you might get some variations in axial forces that you want to review under this graphical option. Otherwise, for most cases, it is enough to review it in this case. Next, we've got torsion. So we can see there's a great deal of torsion within the plate member here. And I'll just skip displacement for now and look at stress. So stress, we have a whole range, different number of stress results that we can look at. Top bending stress, bottom bending stress, shear Y, axial. They're working very much the same way as the other graphs, where you can scale them or isolate each of them and review what's happening there. So displacement, I'm looking at sort of X, Y, Z components. I can turn any of these off at any point just through the clicking here, or maybe just want to look at the sum values of the deflection. And again, I can scale this result just by holding S and scrolling my mouse. And we can even turn on some plate deflection if we want to look at that at the same time, see what the plate's doing. Now that is quite a coarse mesh there. We might want to make that a little bit finer, and we can see really what's happening internally within that plate itself. You can also hover over the areas, so for instance displacement, if I turn these results on, and I can also turn these results off here, so maybe I don't want to look at the result labels, but I can still hover over here and look at what's happening there. And so I've got a cleaner diagram, especially when I start to deflect it, and then I can sort of notice, all right, well that might be an area of concern in terms of how much deflection, how much that node's deflecting, and I can review that independently. And again, might be a good opportunity to take a screenshot. To to include in my report later. So I'm going to turn displacement off, and now we've just got the plate results on, so I can really focus in on what's happening within the internal forces of this plate. So I can turn on membrane forces, so I can actually get a coloured contour of what the membrane forces is doing there. We've got shear force in both planes. We've got moment forces, displacement, so I might look at the displacement sum and see where the, oops, I've got to go, displacement sum, click there. So looking exactly what the displacement is in the middle areas of the plate, maybe that's of concern for my analysis. And again, von Miser's stress might be a critical part of the design that we're looking at. So I can review this in a deflected format, or I can bring that back to the original position, and I'm going to take a screenshot here of that plate. Okay. You can also review in elements as well. So if this is a convenient way for you to review results, you can do element results, and it just shows the maximum kind of stresses in each of the elements, and you can see they're happening in those corners. Otherwise, you might want to review it just in the traditional colored contour way. Now, another thing I can do actually is review all these results through our 3D renderer as well. So the renderer is powerful enough to be able to display results, and I can access it through output there, or through this button just here. So I can actually review my structure to make sure that the deflection, maybe I want to look at the real life deflection, so true deflection there, and I can see that it seems pretty reasonable. There's just a little bit of deflection there, and I can even turn on, say, member results. Let's look at the displacement and confirm that it's only moving 2 inches there in the red. So anywhere where it's red, it's moving by 2 inches as a sum. And I can even exaggerate some of that deflection just to see exactly what's happening within that plate. I can wireframe it, same as before. I can show base. I can show the nodes if that's important, to see where the nodes originally were when the structure was deflected. But for now, I'm just going to include the base and go ahead and I'll take another screenshot and go render deflection. And maybe I want one of the plates as well, under, say, displacement as well. So I can take a screenshot here on the right menu as well. And close that. Otherwise, I can just bring it back to the original structure itself. Maybe I want to include a screenshot of that. So I'll go back to output to wireframe, close that, and another output that would be really important for my structure would be my analysis would be the analysis report. So under analysis report here, or via output analysis report, I can actually create custom reports and what I want to include in my report. So what load combinations I would like, whether I want it in PDF or text format. For now, I'm just going to choose one load combination, and I'm going to include some user-defined screenshots. So it's actually going to show me the screenshots that I've taken throughout the entire analysis. So I might want to consider these two, which were the wireframe results, looking at member 7, and also the plate and renderer ones that were also included. And I can also include what's known as a single member report. So single member report allows you to really focus in on one or a few members that you want to really take a closer look at. So I mentioned that we'd look at an in-depth analysis of member 7. So I'm just going to select member 7 there, and I can choose a whole. I can customize the way I want my report to look. So maybe I want to change what result graphs are being shown. I can even move these around just by clicking and dragging. or adding widgets as well. So I can, maybe I want to delete axial force. There's not really much axial force in that member 7, so I'll delete that. And maybe I want to add another result graph. Just click add, and that one I can do, say, shear stress. I don't think I have shear stress. So I've got shear force. I want to look at shear stress as well. So that'll allow me to really look at the most important results that pertain to member 7. I can also turn on member results and the buckling results that we ran, and also the plate results as well, if that's required. But that's just on a structure like this, it'd probably make it a very long report. So I'll probably just focus on nodal results and some member results. And it looks like I'm ready to run my report, so I just hit create report. Okay, and then it will alert me as to when my report is ready. So I can go ahead and view the report. And it's going to show me just a small window where I can use just a review really quickly if I don't want to save it to PDF. Otherwise, I've got my options here to download it as HTML or PDF. So I'm going to go ahead and download it as a PDF file. And it's going to download to my local drive and open up. And so you can see it's pretty obvious that under the enterprise account, you will have your logo applied there. So it's great for promotional aspects of the business, because you're passing this on to a client or a fellow engineer or someone. They know where that report's coming. It comes in a very professional format. And here we have the full analysis report, so we can see type of analysis that was run, the date at which the report was built, and the file name, what software was used, and obviously the thumbnail there, which immediately allows you to see what structure has been built there and see where the loads are and the supports are, etc. Again, then we've got the contents within the report itself. So we've got job setup, bill of materials. These are the ones we selected in the options when we were producing the report. And so you can see it's a 31-page document in PDF. So job setup basically defines all the information of the structure and how it was built. So I can see I actually didn't save the job name and the designer in the previous when I was building the structure, but we can see the length units, the sections that we use, the nodes, how many members there are, etc. So just a quick review. Then we've got the node coordinates, which shows X, Y, Z coordinates of all the nodes. Members, what fixities they have, the angle. We can see that we've got a few rotated members there. Just allows another engineer to review the structure and the way it was built, and plates, supports, etc. Then we've got load combinations as well, so we can see which combinations have been checked, and these are all loaded from the American, sorry, US design code, ASCE, and you can see that an engineer can review that the correct design codes, correct load combinations have been applied. Bill of materials as well for the members and plates. Then we've got the screenshots that we added throughout the analysis, so we can see here all the different results that we're looking at. Plate analysis, you see deflection with the, we're looking, I think at that point we were looking at the node results and the shear force one that we present. So if you've got a real critical member that you want an engineer to take a look at, say for instance our example is member 7, this is a great way to deliver that to the fellow engineer reviewing this document, to see, okay, I can see exactly the shear force diagram that's occurring within that member. I can see the results, and that's something that I might want to have a second check with. And then we've got the single member report. So this is the one that I selected specifically. I wanted to review member 7, and we can see now that I have a summary of that member, the offsets, the location, the length, what section was used, and I can see where it exists in the diagram itself. So I don't have to actually go back to my model. I can just review that. Yeah, it was that member that we're looking at, and I can see the results, the shear stresses. So it's just a summary of all the stresses here. So I can quickly go over and have a look at the KSI to make sure that that's all within the bounds of structural steel, and whether that's a safe stress that's being that member's undergoing. And I can see here the section that was used, so I can review the shape, W831, the structural steel that was used, so the Young's modulus, and also the geometric properties of that as well. So everything is kind of contained within this one-page document. So if that's really the most important member, I can submit this one-page document and say, hey, look, I've really done a full analysis of that particular member. We've got the bending moment diagram, shear force diagram. Now I could have chosen any results here, and you can see that the deflection, local deflection and stress, but I could have chosen any results. I think I did change this one to shear stress, so we can see shear stress in the Y and the Z. So I'm reviewing both shears, both directions there. And I can review that and make sure that my analysis is done safely. Now, I could have done this on multiple members, so I could have chosen those 4 members. So if I'm looking at a really critical frame, I can basically run this individual report on every single member within my frame. And that just, again, really, it crosses my T's and dots my I's and makes sure that I've done a full analysis on the entire frame by really isolating each of those members and looking at exactly what's happening within those members and producing that in a clean, professional format. Finally, then we have the nodal results, and we can see the load combination that was used there, and we can see the node reactions, the member end forces, so we can see what's happening at either end of each member, and the forces that's being induced within the ends of those members. Nodal displacements as well. Member results, and it even highlights the maximums as well. So I can look at the critical parts of my design. I can look at a whole frame and just kind of scroll through these results and see, okay, well, the max axial force is 80 kip. So is that within the bounds of my safe usage, or do I want to redesign that? And also green being the lowest, red being the highest. So it's capturing both extremes. So I can see the maximum moment at the moment is 103 kip feet, and if I scroll through, I can see no, that's all pretty safe as well. I'm not really worried, and I can quickly review parts of the max and mins of each result, and I can say, okay, well, the maximum there was about 103 kip feet in terms of moment. Is that satisfy my criteria? And it just goes that extra mile for analysis to show you the information you really care about and you really want to know within this document. So again, looking at displacements, I might want to look at what the max mins displacements are, and it looks like if there's multiple ones, it just means that it's the same result. So I can see 0.05 inch is the maximum result in terms of global Y. It might occur a few times within the model, maybe because those nodes are connected all at one spot, but I know that maximum is 0.05, and for this one's 0.008. Very reasonable numbers. So again, quick review of the analysis report. And I think we're into the stress, I'm not sure. Yep, so local displacement, so we just did global displacements, now looking at local. And member stresses, so it's got a full in-depth look at all the results of the structure of the analysis. And that should be the end of the report. So I've got that document. I can then again forward that, save that. It's saved within my on the cloud as well, so I can save that in the cloud and refer back to that at another time. And I've got that to use for compliance or whatever other reasons I need that report for. And that's saved locally to my drive as well as I hit download PDF. So that's the post-processing part of the structural 3D program. So that's how you review your results. Again, toggling buttons, 3D renderer, and reporting are some really great ways to review these results of your structural analysis. So thank you very much, and look forward to seeing you on the next video.